Welcome, geometry students, to lesson 2-3 on parallel lines and the triangle angle sums, right? So this is a big idea in our geometry class, triangle angle sums. You might actually know it, but let's get after it. Here we go. So let's do some investigation. It says, investigate the measure of the triangle's angles. What appears to be the relation between the angle measures of a triangle? So let's take a look here. It says experiment with this. So let's click on this and see what happens. Right. Oh, give me 1 second. Let me pause the video. All right, so I got it brought up here. All right, so we're just going to play around with these three angles. Now, notice that the three angles are copied down here. So if I change this triangle, notice how the angles are changing, right? Right, so angle one's getting more obtuse. We can make angle two less acute. We can try to make angle three obtuse, right? Okay, all that fun stuff. But notice what stays constant down here is this idea that angle one, angle two, and angle three combine to make this straight line. And we should know that a straight line has 180 degrees. So the big idea from that is that the three angles in a triangle add up to 180. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 from this triangle will always and forever be 180 degrees. This is a huge idea you might have known coming into this class, but again, don't ever forget it. All right. Cool. All right, so let's come back here to our notes. Let's see if I can get us back in. Yes. Okay. So here we go. So we got to talk about this theorem called they call it the parallel postulate of the books, but it's a theorem here, 210. It says through a point not on a line, there is one and only one line parallel to the given line. So in this picture here, you would essentially start with line B and point P, and you would draw line A through point P, and line A is the only line parallel to line B that passes through point P. So that's a lot of words, I'm sorry, but you're going to see where it's useful looking ahead. Okay, so here's your triangle angle sum theorem, which we kind of discussed already. So the sum of the measures of all the angles of a triangle is 180. So the sum of the angles of a triangle is 180, right? And again, this is what we wrote down in the other slide with 1, 2s, and 3s. So again, if you look over here, 45 plus 75, plus, getting ahead of myself, plus 60 equals 180. Okay. And we're going to go ahead and take a look at this triangle in Savas, and let's do some manipulation to it. So let's go with, let's try to make angle C 80. Let's make, I'm sorry, it's going to change them all. Okay. I think I did this before. So there you go, 50, 51, and 79, right? So 51 and 79 is 130, and 130 and 50 is 180, right? So no matter what we do, those three angles will always add up to 180. Cool. All right. Okay, so let's take a look here. So we're going to prove the triangle angle sum theorem, right? So we're given a triangle. We want to prove that the measures of angle 1, 2, and 3 are equal to 180. And we're going to do what's called a paragraph proof. I think we've done this in the past. This is my least favorite because we have to write. And again, I'll do my best to write as neatly as I can. So the first thing we're going to do is we're going to apply Theorem 210 from 2 slides ago. So apply Theorem 210. Oh, applying Theorem 210. Draw line L through point C. Such that L is parallel to segment AB. So that's our first step. So I'm going to do that here. I'm going to draw a line parallel to AB through C, call it line L. We'll mark it parallel using the arrows. And notice that it creates a couple more angle positions here. I'm going to call this angle 4 and angle 5. Those will be helpful later on. Okay. And notice we have this straight line. So if you recall, right, the straight line is 180 degrees. If you think back from that, the very first slide we did today. So, okay, so second step. So by the angle addition postulate, the measure of angle 4 plus the measure of angle 5 plus the measure of angle 3 is going to be equal to 180. Right? This is a straight line, has 180 degrees, add up the three angles. Notice I put them in a specific order because if you see how angle 3 comes last, I want to put angle 3 last. Okay. And now, since we brought up parallel lines from sections 1 and 2, or lessons 1 and 2 of this topic, we can use the alternate interior angles theorem. So step 3, by the alternate interior angles theorem, we should know that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 5. So in this picture here, we have parallel lines cut by transversals AC and BC. Angle 1 and angle 4 are congruent. Angle 2 and angle 5 are congruent. If the angles are congruent, then we know their measures are equal. So then the measure of angle 1 is going to be equal to the measure of angle 4. And the measure of angle 2 is going to be equal to the measure of angle 5. By the definition of congruent angles. And since these two angles are equal, so we're going to substitute the measure of angle 1 for the measure of angle 4, and the measure of angle 2 for the measure of angle 5. So by substitution, in this equation right here, we're going to take out angle 4, put angle 1. We're going to take out angle, not angle 3, sorry, ignore that. We're going to take out angle 5, put angle 2. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 will equal 180. And we proved it. And that's your theorem, right? This is a pretty big time theorem to prove. You might see this on the Ohio State test. They kind of like to throw it in there. But again, if you know it's about parallel lines, alternate interior angles, you should be fine. All right, so here's video 1. Video 2 is coming right up next.